this is section 3.2, radians in degrees. So here's the definition of a radian measure. It's given by the central angle theta, the radius of the circle, and the arc length given by s. So by definition, theta in radians is given by the measure of the arc length divided by the radius, so s over r. So that's a formula to figure out what theta is in radians, right? All right, so let's convert 45 degrees to radians. Well, we know that 180 degrees is equal to pi radians. So we're going to use that ratio or that identity in order to convert. So we start off with what's given to us, which is 45 degrees. And since we want to cancel the degrees out, we need to multiply by the ratio of 180 in the denominator so that we can get the degrees to cancel, and pi radians in the numerator. So if you do that, you're going to get these units to cancel, the degrees to cancel out, and you're going to end up with, if you multiply 45 over 180 pi radians, and we can simplify by 5. Let's see, 45 divided by 5 is 9, so that simplifies into 9 out of, or over, 36. And then we can divide by 9, which is 1 over 36 pi, which you can just write as pi over 4. So that's how you would convert from degrees to radians. You multiply by this ratio. All right, and you get the units to cancel out, and then you're left with the radians, which is what we wanted. All right, let's try this one. Same thing. But this time we're going in the opposite direction. We're going from radians to degrees this time. So you start with what's given to us, which is pi over 6. And this time you're going to multiply by the ratio of 180 degrees in the numerator this time, and you want pi radians in the denominator. Because this is in radians and this is in radians, so those are going to cancel each other out. The radians cancels with the radians. I didn't write radians here, but I mean, it's understood that this is in radians because they tell you. And so the radians are going to end up canceling, and you're left with 180 degrees over 6, which is going to be 180 divided by 6 is 30 degrees, right? 30 degrees. So that's how you would convert from radians to degrees. All right, now we can find out what this is. Well, if you're looking at your unit circle, that's probably the easiest way to go about this. You can just look at your unit circle, and pi over 6, as we just found, is 30 degrees, so that would be about right there, 30 degrees. And this has a coordinates of radical 3 over 2, comma 1/2. And since we're looking for sine is a y-coordinate, which is equal to 1/2. All right, same thing with this. I like to draw the angle in the correct quadrant. So if you're looking at your unit circles, we're going to go by 6s, pi over 6. So that's 1 6, 2 6, 3 6, 4 6, 5 6, 6 6, 7 6 is right there. So 7 6 is right here. 7 6 pi, which is 30 degrees more than 180. And the coordinates for this angle would be negative radical 3 over 2, comma negative 1/2. And since we're looking for sine of that angle, it's going to be negative 1/2. But notice that you have a 4 in the front. So the 4, you're going to multiply that by whatever this is, which we see is negative 1/2. So it's going to turn out to be 4 times negative 1/2, which is negative 2. This is our final answer. All right, that does it for the notes. Let's look at the homework now. So this is a fill in the blank. I'll leave that for you guys. So they want us to figure out what the radian measures of these are, which we've already done both of these, so I'm going to skip those two. Let's go to 60 degrees. So 60 degrees, that would be 60 degrees, and we multiply by the ratio of pi over 180 degrees. Notice I put the 180 in the denominator so I can cancel out the units. And that's going to give me 60 over 180 pi, which turns out to be pi over 3. So that would be the conversion, which is right there. And I will skip 90, but you would do the same thing and you'd get pi over 2. All right, for number 3, they're asking us to find the radian measure, and they give you the radius and the arc length this time. So if you recall from the notes, the degrees, or I'm sorry, the theta, the angle, is given as s over r, where theta will be in radians. So you have 10 centimeters divided by 5 centimeters, which is just 2 radians, which is our final answer. All right, for number 3, same thing. You're doing the same exact thing. Theta is equal to s over r. S is given to us as 5 pi inches divided by 15 inches. And that's going to simplify into pi over 3 radians. All right, here we have 2 cities that are separated by a miles. And we have the radius of the Earth, which is 4,000 miles. And so the question is asking us to find the radian measure of the angle that's in between, the central angle, essentially. So same thing, that's going to be theta is equal to s over r. S is the arc length given by this distance, which is given to us as 650, divided by the radius, which is 4,000 miles. And you want to make sure that the units are the same, miles, which they are. So that means we don't have to do any conversion. So if you divide these two numbers, you should get 650 divided by 4,000 is 0.1625 radians. So that would be the measurement of the central angle. All right, in order to simplify this expression, we can get a common denominator of 6. So 6 is our common denominator, which means you have to multiply top and bottom of this fraction by 6. That's going to be 12 minus 1 pi. 12 pi minus 1 pi is 11 pi. And that is the final answer. Notice you can put pi off to the side, or you can put it in the numerator. Either one is fine. So you can choose. For this next problem, they want us to write the angle as a sum or a difference involving pi. They give us an example. 5, 6 pi is the same thing as pi take away pi over 6. So we're going to do something very similar to here. We're going to think of 9 over 9 pi minus 8 over 9 pi is pi over 9, right? So in order to get this isolated, we'd have to add this over and bring this over. So that's the same thing as saying pi minus pi over 9 is the same as 8 over 9 pi. So I just reversed this one. I brought this over to the left side by subtracting it, and I brought this over to the right side by adding it. And so this is your final answer. All right, same thing for this problem. This looks like you're going to be adding. They want it as a difference. So let's see if we can figure out a difference for this one. Let's see. They want it to involve 2 pi. So 2 pi is the same thing as 8 over 4 pi. The reason I chose 8 over 4 is because this has a denominator of 4. That's why I chose to convert this to 8 over 4. So now if you subtract, you're going to get, let's see, we're probably going to have to do 2 pi minus 1/4 pi. So this is that 8/4 pi, take away 1/4 pi is 7/4 pi. And so this should be our answer here, because 2 pi minus 1/4 pi is 7/4 pi. So this is our answer. All right, moving on. So they want us to draw this in standard position. So that would look like this. So I like to go like this: 1/4 pi, 2/4 pi, 3/4 pi, 4/4 pi, 5/4 pi. So literally, every 45 degrees, I count an extra 1/4 pi. So 1/4, 2/4, 3/4, 4/4, 5/4 pi. So here's our angle. It's right there, and it's going in this direction. So it would be this choice here. All right, and then to convert that to degrees, well, we have 5/4 pi. So we start with 5/4 pi. And since we want to convert that to degrees, we're going to multiply by pi radians on the bottom and 180 degrees in the numerator. That's going to cancel out the radians and the pi's. And we're left with 180 times 5 divided by 4. So 180 times 5 divided by 4 is 225. And that should do it. Yes. And then label the reference angle in both degrees and radians. All right, so 225 is approximately, well, we said it's over here. All right, so in order to find the reference angle, you would do 225, take away 180, because our reference angle is this one here. This is our reference angle. So you have to subtract these two values, and that's how you get the reference angle. So 225 minus 80 is 45 degrees. And that would be the degrees. And we already know that 45 degrees is equivalent to pi over 4. And if you didn't know that, you can always do the conversion similar to what we did here. All right, you could do 45 degrees times the ratio of pi over 180. And that's how you get these to cancel out. And that's going to become pi over 4. All right. Use a calculator to convert the following to degree measure to the nearest tenth. All right, so this is in radians. So we have 1 radian. And once again, we use our ratio, pi radian in the denominator, 180 degree in the numerator. Cancel the radians out. And then you would use your calculator, and you would get 180 over pi, which is in degrees, and that's going to be 180 divided by pi is 57.29, but they want us to round to the nearest tenth of a degree, so that's going to be 57.3 degrees. All right, give the exact value. So I always like to draw the angle in standard position, which would be pi 6 is 30 degrees. Would be about right here. And then that coordinate would be radical 3 over 2 comma 1/2. And because tangent is defined as y over x, I'm going to do 1/2 divided by radical 3 over 2, which is the same thing as 1/2 times 2 over radical 3, which is the same as 1 over radical 3. You can choose to rationalize the denominator if you like, but you don't have to. All right, this one's going to be very similar. I'm going to start off by drawing the angle in standard position. Negative pi over 4 is negative 45 degrees, which would be right in the middle of those two angles in quadrant 4. And that coordinate would be radical 2 over 2 comma negative radical 2 over 2. That's the fourth quadrant. And since we're looking for cosine, that's the x coordinate, which is radical 2 over 2. So this is going to be 6 times radical 2 over 2, which is going to become 3 radical 2. Is our final answer. All right, the last one. They tell you what x is. They want x to be pi over 6. So let's substitute pi over 6 for x. That's going to be 8 sine of 3 times pi over 6, which is going to become pi over 2. 8 times sine of pi over 2. Well, On the unit circle, pi over 2 is 90 degrees, which has a coordinate of 0, 1. And because we're looking for sine, that would be the y coordinate, which is 1. So this is going to be 8 times 1, which is 8.